It's an activity we are doing, we are having at LNE, the French National Laboratory for Metrology and Testing. And as it was said by Javier, I'm head of the AI evaluation department at LNE. So basically today, the scope of the presentation would be to be able to identify the challenges and means that are related to the evaluation of artificial intelligence system. It can be for the development of AI system, can be for the certification, for the maintenance phases, and so on. So we will discuss about the evaluation criteria for artificial intelligence. We will be discussing about the regulation, all the rules, the laws that are related to the deployment of these artificial intelligence systems. And also we are going to discuss about the means related to the conformity assessment of these intelligence systems. So LNE, for those who don't know, LNE is having metrology, testing, and certification activities in many different kind of applications for different kind of products. So that's why we have an activity that is dedicated to artificial intelligence, because there is right now it's a new kind of technology that is entering the market. So there is a need for evaluation, there is a need for characterization of the performances, and so on. And that's why there is this team. But you can also find other kind of team, for example, a team that is dedicated to cybersecurity, a team that is dedicated to nanoparticles, and so on. So the reason why we are interested in evaluating artificial intelligence system is because, as you know, for the moment, AI is mainly a buzzword, and we want to make sure that AI supply is getting closer to AI demand. So on the supply side, people are developing black box non-convex evolutive systems, whereas on the demand side, people and users are looking for trustworthy and efficient functionality. So to make sure that these black box are conform to what end users are looking for, there is a need for evaluation. It's the same thing for artificial intelligence as it was in the past, or I mean, even right now, but it's the case for other kind of products that are entering the market, where we want to make sure that the products are in conformity, are compliant with the requirement of end users and regulations. To take an example, for industrial robots, you can find artificial intelligence basically everywhere. You can have artificial intelligence system for natural language processing, so to interact with a voice with workers, for example, to control the robots with voice as a personal assistant, for a speaker recognition application. You have also artificial intelligence system for predictive and preventive maintenance, for collaborative robots, for I don't know, surveillance robots, and so on. So basically, you can have voice recognition system, image recognition system, dexterous manipulators, and so on. All of this embedded on an industrial robots, and you want to make sure that this robot is not dangerous, that it is efficient, that it has good performances, and so on. So at LNE, we have different kind of sub-activities that are related to the evaluation of artificial intelligence systems. The first one is, let's say, a theoretical activity, because we are developing evaluation standards, metrics, evaluation protocols, and so on to evaluate the performances of these AI systems. And there is a second activity that is about testing this AI system. So basically, we are using the metrics and the evaluation protocol that we developed in the activity number 1 in order to evaluate these AI systems. The third activity is about the certification of artificial intelligence systems. So it's basically conformity assessment. It can be voluntary, or it can be for regulation purposes. We have an activity that is dedicated to the development of evaluation tools. So, for example, for data augmentation, to evaluate an artificial intelligence system, we need data sets. So in some cases, we need to do data augmentation to make sure that the data set is representative of the operational the operational environment of the AI systems. And there is a fifth activity that is about transfer of this know-how, of these skills that are related to AI evaluation to standardization committees, to universities, and so on. Since the activity was created at LNE in 2008, so more than 12 years ago, but at this time we were not speaking about artificial intelligence. We were speaking about information processing system, but basically the fundamentals of these two activities are the same, and we have evaluated more than 900 artificial intelligence systems since 2008 for different kind of application that I'm going to speak about in the next slide. And we have more than 15 ongoing projects to R&D projects in order to make sure that we are able to develop new metrics and the evaluation protocols for the new application of artificial intelligence systems. At the beginning of the creation of this activity, we were dedicated to speech and text processing. So we were basically evaluating speaker recognition systems, name entity recognition systems, transcription, translators, and so on. And then we developed the activity to be able to evaluate image processing systems, such as for object recognition, for person recognition, people recognition, sorry, and so on. And 6 years ago, maybe, we started develop tools to evaluate robotic systems. So right now we are evaluating autonomous cars, medical devices, agricultural robots, and so on. So basically we are trying to develop the evaluation protocols, metrics, standards, and tools for any kind of application areas for artificial intelligence. But really we are dedicated to evaluation. It means that to not be to avoid any conflict of interest, we are not developing AI system. We are dedicated to the evaluation of these intelligent systems. So let's discuss about the AI requirements. The evaluation is important for AI through the life cycle, because you will need it at the development phase where you are developing the AI system. You need evaluation to make sure that you are developing your different technological parts in the right direction. So you need to benchmark them. You need to maybe make sure that all the different technological parts that are embedding AI are efficient, that they are the best on the markets, and so on. So you need evaluation for the development of these systems. Once you have finished develop your artificial intelligence system, you also need to put it on the market, to commercialize it. So you need conformity assessment, and it's also a conformity assessment. It can be audit, it can be testing, but you will need evaluation, for example, for CE marking, if you want to commercialize your artificial intelligence system on the European market, because it's a medical device or because it's a machine, and so on. And you can also use a voluntary certification, because you want to demonstrate to your customers, to your end users, that your product is better than the competition. So basically, you can also rely on conformity assessment as let's say for marketing purposes. And on the end user side, this end user that is looking for, I don't know, he wants to buy a chatbot, and there are thousands of chatbots, different kind of technologies that are existing on the market. So this end user will need to benchmark the different technologies that are existing on the market, and that's why we are collaborating with end users to do this comparative analysis, this benchmarking, to be able to compare the performances of the different artificial intelligence systems that are deployed on the market. And finally, once the end user has bought an artificial intelligence system, then you will need to monitor it, to do maintenance. You will need to do acceptance tests, of course. You will need to be able to measure possible drifts, possible performance regression once the system is deployed. So you need also evaluation at this stage of the product lifecycle. And evaluating an AI system is not exactly as evaluating any kind of software, because basically an AI system is called intelligent because he has adaptability skills. He's able to adapt to its environment that can be changing, that is open, that is sometimes unstructured. So it's you basically, when you want to evaluate an artificial intelligence system, what you need to do is to evaluate the size of the operating environment of this AI system, to be able to say, okay, in these conditions, the artificial intelligence system work, and in this condition, it does not work. So it's one very important thing. Second, the artificial intelligence system, especially deep learning technologies, they have a non-convex behavior. It means that it's not possible to only do some sampling about the operating points to evaluate the performances of the AI system for Y1 point, 2 point, 3 point, and then by interpolation and extrapolation to be able to estimate the performances of the AI system on the whole operating environment. You cannot do that. So because it's not convex. So what you need to do is to do sampling and to test to do statistical testing of the performances of the AI systems. The AI system it's said to be black box because when you look at the deep learning algorithm, for example, you have a million parameters. So basically, you can open the box and look at the values that are taken by these parameters, and it does not provide you any information related to the real performances of this AI system. So that's why you need to do input-output testing, because it's just looking at the code is not enough. And this artificial intelligence system can be evolving, meaning that once they are deployed, some of them are able to continue to learn. We say that they have lifelong learning capabilities, and so maybe you will need to evaluate every 2 hours, every day, every week, every month. We don't know, but you will need to evaluate regularly the performances of this AI system, and it's something that is new in comparison with other kind of software where you can you certify it, and you can certify it, I don't know, for the life of the whole life of the product, or you can certify it every 2 or 5 years, but you don't need to do it every day. So it's a new problem that is related to artificial intelligence system with lifelong learning capabilities. The connection, sorry about that. The connection with the metrology is really important, because to evaluate to characterize the operating environment of this AI system, you need to develop new metrics, new measuring instruments. They are not existing at the moment. You can rely on simulators, you can rely on physical test benches, but these different kind of testing environment are not existing yet on the market. So there is a real need for metrologists to work on this topic, to make sure that we are able to measure with an uncertainty that is that can be estimated the performances of this AI system. Looking at the evaluation criteria, you of course you will be interested in evaluating the performances, the robustness, the resiliency of this artificial intelligence system, but you can also be interested in evaluating explainability of this AI system, meaning the capability of the AI system to be able to explain why it has taken taken this decision or this other decision, and so on. It's also interesting to evaluate, and there is a connection with the European regulation that is under development, to evaluate the ethics of artificial intelligence system, to evaluate the quality of the human-machine interaction, and so on. And of course, energy consumption, the efficiency of the AI system. And for example, at LNE, we are comparing, benchmarking digital AI with analog AI and neuromorphic AI in order to see if there are new kind of approaches that are less consuming in energy in comparison with digital AI, traditional digital AI. And so there are different kind of work, standardization works at an international level. So of course, at the national level, there is a AFNOR that is working on it. At the European level, it's the Sensenelec JTC 21, and at an international level, we are also involved at the JTC 1 SC42. So it's the ISO-IEC standardization committee for artificial intelligence, and so if you are interested in these topics, you can definitely look at what is the ongoing work at ISO-IEC JTC1 SC42. And now let's talk about the existing tools and those to be set up for the evaluation of artificial intelligence. First, let's present the traditional, classical evaluation method for AI. Generally, what you need to do, it's the first, let's say, line of the slide. The first thing to do is to define the evaluation task, to formalize it, and then once you have done that, you can develop the testing data set, the testing environment, and then, for example, let's say you want to evaluate the performances of an AI system that is supposed to recognize cats and dogs on images, on pictures. Then you will need to ask human experts in cats and dogs to say where are the cats and where are the dogs on the pictures, and then you will compare what these answers from human that we call references. You will compare references with the output of the AI systems, and thanks to comparison metrics, you will be able to estimate the distance between references and system outputs in order to be able to estimate the performance of this the AI systems. And this evaluation protocol, you can use it for, if you are doing a gray box evaluation, then you can, for example, use one matrix for each technological part of the system. So, for example, you can use one matrix for recognition, one matrix for understanding, one metric for mission management and generation of action, and so on. But sometimes it's not possible to. You can generally do that when you are evaluating the AI system on the behalf of the developer of the technology, because the developer will allow you to open the box to define all these different metrics. But when you are evaluating for the end users, then generally it's black box testing. It means that you can only do input-output testing for the whole system, and you cannot open the box. So let's take an example, a very simple example. We were evaluating the performances of agricultural robots. So basically, the first step was to collect pictures of crops and weeds, and to ask human expert to annotate the images, to say where are the crops, where are the weeds on each picture, and we were comparing this human annotation with the output of the AI systems, and thanks to a comparison matrix, as I said before. And the other kind of tools that are useful for evaluation of AI are, as we say, the data sets. So we need data augmentation. Maybe you will need also to rely on new techniques that are relying on artificial intelligence to generate what we call the corner cases, adversarial attacks for the AI system, in order to really precisely characterize the operating environment of this AI system. You will also need to have labeling tools to automatically evaluate applying the metrics to evaluate the performances of the system, develop the testing environment, and so on. And there is a real trade-off between simulated environment, simulators, virtual testing for artificial intelligence, and physical test benches, because with simulators you can generate a lot of different kind of testing conditions. For example, you can have different kind of weather condition, you can have different kind of obstacles, and so on. So you can be really complete, really exhaustive in the exploration of the operating environment, but it's not really realistic. But you are not sure it's realistic because it's a simulator, right? So there is a maybe you need to compare some result of the simulators to results that you have that you are recording from physical testing. And so at LNE, we have a investment program that is called LEIA, for Artificial Intelligence Evaluation Laboratory. And it's really about developing all these different kind of testing environment with simulators, with physical test benches, in order to evaluate the performances of these systems. I don't want to take to be too long, so I will finish quick. But there are also organizational tools. So it means that it's not only about software for the metrics or data augmentation and so on. It can be also the organization of challenges with one evaluation campaign, for example, each month or each year, in order to be able to evaluate the progress made by AI technologies. And with these challenges, what is really interesting is that it generates, how to say that, like a real collaboration between the stakeholders around some difficulties, some problems, some issues related to a specific point of tasks that need to be automatized by artificial intelligence system. So relying on this kind of challenges, you are really making progress in AI. And we are coordinating a consortium of 17 European partners to organize such kind of challenges at a European level for robotic systems. I will finish this presentation with certification. We developed the first, we think it's the first certification for AI worldwide. It's a process certification. We were thinking about developing a product certification or a process certification. And with the working group, we consider that product certification at the moment is really difficult, because you will need to have one testing data set, and for each kind of application, for each kind of artificial intelligence system. And as the artificial intelligence system is able to learn, then you will need to renew the each testing data set, after each evaluation. So it will cost a lot of money to do a product certification, whereas with process certification, you have a first level of guarantee to make sure that the process that allows a company to develop AI system are in agreement with the guidelines, with the good practices, and so on. It's a first level of guarantee, and then we can do, for specific critics application, it will be possible to do product certification. And so in this certification at LNE, we are considering design process, development process, evaluation process, and maintenance process. So thank you very much for your attention, and please do not hesitate to ask any question you may have. Muchas gracias a todos, y que sea las preguntas pueden ser en español o en inglés, no hay problema. Gracias.
Okay, thanks a lot, Guillaume, for your presentation. Really good presentation, I have to say. We're going to start with the first round of questions, but before we do that, I'd like to take advantage of me being the moderator so that I can ask the first question. At the beginning of your presentation, you mentioned something about information processing system, and that was when we kind of started the artificial intelligence processes. Could you mention, if there is any, what could be the differences between the actual artificial intelligence and the previously information processing systems, if there is a difference?
Of course. Thank you for the question, Javier. I would say that it's mainly a difference of algorithm, of approaches for AI, because right now what we observe, for example, at LNE, our customers are mainly into, I would say 80% of them are mainly interested in deep learning or machine learning approaches. And this is kind of new, because before we were more considering expert systems, so symbolic approaches. And there is a difference, because with expert system, with symbolic approaches, for example, you can try to rely on what we call formal proof, for example. So you can try to demonstrate mathematically that the code is good, that the system is doing what you want. You can do that with, sometimes you can do that with an expert system, but it's sure that you cannot do that with deep learning, because with more than 1 million parameters in your system, it will not be possible to demonstrate it formally. So you need to do statistical testing, and that is kind of new. The behavior that is non-convex, that is non-linear, with these new approaches for machine learning, makes the testing part and the conformity assessment part more difficult than what was done before.
Okay, thanks a lot, Ian.
Thank you.
Good answer. Okay, also here we have a question from Francisco Flamengo. Actually, two questions. First one says, and I think it is based on all the information that you just gave us. First question will be, how many people you have at LNE working at this moment in artificial intelligence? And second, it's to create solutions. Do you develop all the elements of the system, or do you make use of some general purpose developments already from, let's say, outsources?
It's a very good question. Thank you very much. So at the AI evaluation department, at the moment, we are 20 people. We try to have PhD student, postdoc, and a traineeship every year, in order to also increase in a little the R&D part of our activity. But yes, approximately 20. So I don't know if we have people from the NIST here today, but the NIST is also having this kind of activities related to the evaluation of artificial intelligence. And from what I know, there are more than 60 people working on it. So we are not that advanced, but yeah, we are trying to develop, to continue developing this AI evaluation activity. And but there is also something that is important, is that at LNE there is another team that is not the AI evaluation department, is a team that is dedicated to the development of AI systems for metrology application. So basically, we can say that I'm concerned with, I'm about metrology of AI, and they are more interested into AI for metrology. And it's two different kind of activities with two different teams. Yeah. And regarding the second part of the question, that about the tools that we are using for AI evaluation, so it's true that at the moment we are mainly using tools that we developed ourselves. So basically, in the team of 20 people, there are something like 5 of them that are programmers that are programming tools for evaluation. But for example, for the evaluation of robots, we are going to have, we don't have them yet, but we will have them next year. We are going to use the ASTM standard module to benchmark, to evaluate robotic systems, and I think they were developed by NIST in particular. So yeah, we are going to start integrating tools that are coming from elsewhere in our processes. But for the moment, it's mainly our tools.
Okay, thanks a lot. Thanks a lot. There's a lot of job actually to be done. Okay, here we have another question. This is from our friend Alexis, and we have a couple of more questions, so we'll try to be fast asking them and please also answering them. Alexis asks, how important is the metrological traceability of the data used when developing and or certifying AI systems? And do you have cases of examples where the lack of metrological traceability of data limited the AI system or its certification?
Mm-hmm. It's a good question, an hard question, because I think I know I need to do short, But so I think you can, for example, you want to evaluate the performances of robotic systems that are driving autonomously or avoiding obstacles. Then the unity that you are using is meters. Or you can also use seconds to evaluate the performances of AI systems. So with this kind of unities, then you can the traceability of this of the measurement is really important. But the problem that we have, for example, I was speaking about do a recognition of cats and dogs on pictures. Then we don't know what traceability is. In fact, it's really a metrologist problem. What is the ground truth? What is the standards for it? How you make sure that there is a you know the ground truth associated with the data. It's something that it's not solved yet, and we would love to work with other metrology institute on this topic.
Okay, thank you. We have 3 more questions. One will be related to this one actually, and it says, I want to read in Spanish and in English. Actualmente existen esquemas de evaluación de la conformidad que sean implementados por certificadores. Basically, do we have any scheme that you can use for certifying these processes?
Yeah, so in fact, yes, there is the certification standard that was developed by LNE in June 2021. So this one is existing and it's free. So you can download it on internet. Then if you are interested, I mean, the developer of this AI technology, they can pay for being audited for certification, but the standard is free. And we think for the moment that it's the only standard that is existing on the market. But from what we know, there are other initiatives. For example, Fraunhofer is working on a certification standard in Germany. So there are other kind of initiatives. But for the moment, I think it's the only one.
So there is only one for the moment that maybe it's being used all around the European Union. Okay, we have other question from Hugo Gasca. Congratulations, first of all, for your presentation. How do you deal with the implicit bias in the input databases to train the test of AI systems?
Yeah, good question also. So there is a real topic that is about the representativeness of the data we are using for testing. So we are trying to evaluate the statistical distribution of some influence factors that are inside the testing dataset to make sure that these influential factors are distribution is in agreement with the one in the real operating environment in order to avoid any selection bias or any kind of bias related to the testing part for the AI systems, but it's hard. We need to make sure that the data are exhaustive. We need to make sure that they are realistic, and it's something that there are no well-defined metrics for that. So we are trying to develop our own metrics for the moment, and maybe why not develop standards about that.
Okay, one last question regarding that one also. What technological infrastructure is necessary to develop and maintain AI applications? And if you can join that with, now you were talking about standards, what are some of the standards or metrics that you're using for that AI systems?
Yeah, I'm not really an expert about how to develop and maintain AI application, because really we are into evaluation of AI. But what I would say that to develop an AI system, you will need, of course, clusters to do calculus to make sure to train your AI system. You will need dataset, learning data. Dataset to learn with your AI systems, and then to maintain it, you will need monitoring tools to make sure that there is no drift, there is no performance regression, and so on, when the AI system is developed. But the standards for that are under development at the moment, at the ISO YEC level, at the Sentinel level, and so on. And also IEEE is also working on it, and I'm sure I'm forgetting others. So you can find some of this work right now ongoing.
Okay, thanks a lot, Guillaume. You're finishing right on time, so good meteorological timing. I'd like to give you a round of applause. So if we can all please clap our hands for Guillaume at this time. Great representation. So thanks a lot to you and to all the friends in Europe over there. Thank you for your presentation. Gracias por estar con nosotros.